Lesson 10-4. Use inscribed angles and polygons. By the end of today's lesson, we will be able to successfully use inscribed angles of circles. The inscribed angle is an angle whose vertex is on a circle and whose sides are chords of the circle. So, let me show you an example. This will be called an inscribed angle. And the next one, intercepted arc, is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So here, from this point to this point, this would be called the intercepted arc. And this would be the inscribed angle. And for the inscribed polygon, we would have for example, maybe a quadrilateral whose vertices all lie on the circle. And the circumscribed circle would just be the circle that contains the vertices of the inscribed polygon. So this we will refer to as the circumscribed circle around the polygon. And this is the inscribed polygon. So in means inside, circum means around the circle. Theorem 10.7, measure of an inscribed angle theorem. It states that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So measure angle ADB is equal to 1/2 of measure arc AB. I would like you to refer to my website to see how I prove this theorem by referring to 3 cases of an inscribed angle, where the first case will be that one side of the angle will be the diameter, and the second case will be that the inscribed angle will be this wide with the center in between the 2 angles, and the third case will be an inscribed angle in which the center is outside of the inscribed angle. And no matter which way you use to prove, it will always end up with this formula. So please take a look at the 3 proofs, and then I will also explain the proofs in class. Example 1. Find the indicated measure in circle P. Part A. We would like to find the measure of angle S. Well, since angle RST is an inscribed angle of the circle P, and you're given the measure arc length of RT of 60 degrees, so measure angle RST must be 1/2 of 60 degrees by theorem 10.7. So that's 30 degrees. Now we want to find the measure of arc RQ. So since we know that angle QRS is 37 degrees, then the measure of arc QS by the formula in 10.7 must be 37 times 2, which is 74 degrees. Now since measure arc RQS is a semicircle, then measure arc RQS should be 180 degrees. And by the arc postulate, I could set this equal to arc RQ plus arc QS. So 180 degrees equals question mark, I don't know, and QS is 74 degrees, then measure arc RQ should be equal to 106 degrees. Example 2. Find the measure of arc HJ and angle HGJ. Okay, so I know that angle HFJ is 39 degrees. I could double that, which is 78 degrees. So my measure for arc HJ is 78 degrees. And I can also look at it from this point perspective. So I know that angle HGJ is half of the measure of arc HJ. So half of 78 again is 39 degrees. So what do you notice about angle HGJ and angle HFJ? They're equal to each other. So I'm going to put the M in the front. Or you can say angle HGJ is congruent to angle HFJ. Example 2 sets the stage for Theorem 10.8, meaning if two inscribed angles of a circle intercept the same arc. So we have angle ADB and angle ACB intercepting the same arc AB, then the angles are congruent. So angle ADB is congruent to angle ACB. And you can quickly prove this by using substitution and Theorem 10.7. And please refer to my website, and I will also go over the proof in class. Example 3. Name two pairs of congruent angles in the figure. So here I'm going to put an S because it's cut off, and I could say angle PSQ is congruent to angle QRP because they intercept the same arc PQ. And then you can also say angle RQS is congruent to angle SPR. Because they intercept the same arc SR. Example 4, find the indicated measure. So we're going to practice using the theorems that we just went over. Since arc GJ is 100 degrees and angle GHJ is the inscribed angle, so angle H should be half of 100 degrees. So angle GHJ is just 100 degrees times 2, which is 50 degrees by Theorem 10.7. And the measure of arc CD, again by Theorem 10.7, we just have to take the inscribed angle of 40 degrees and double 2. Times 2, I mean. So that's 80 degrees. And for measure angle RTS, since it shares the same intercepted arc as angle RQS, and angle RQS is given 31 degrees, then angle RTS must also be 31 degrees by Theorem 10.8. Theorem 10.9. If the right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And conversely, if one side of the inscribed triangle is the diameter of the circle, then the triangle is a right triangle. And the angle opposite the diameter, so this is the angle opposite the diameter, is a right angle. Now, this sounds very familiar, right? The circumcenter, where the center is the midpoint of the hypotenuse. Again, I will go over the proof in class as it takes a little while to explain. So just to summarize again, measure angle ABC is 90 degrees if and only if AC is a diameter of the circle. Now example 5, a security camera rotates 90 degrees and needs to be able to view the width of a wall. This camera is placed in a spot where the only thing viewed when rotating is the wall. You want to change the camera's position. Where else can it be placed so that the wall is viewed in the same way? So from theorem 10.9, we know that if a right triangle is inscribed in a circle, then the hypotenuse of the triangle is the diameter of the circle. So this one. Draw the circle that has the width of the wall as the diameter. So this should be width. And I could do this. The wall fits with the camera's 90-degree rotation from any point on the semicircle in front of the wall. So how do I show that? So if the camera rotates, then I could do the triangle, right triangle would change in position. But it will still fit the wall. The hypotenuse will still fit the wall, I mean. Okay, and it can also change to this position. And still fit the wall. Theorem 10.10 states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, which means that angles D, E, F, G lie on the circle C if and only if measures angle D plus measures angle F equal to measure angle E plus measure angle G, and which equal to 180 degrees. Again, I will prove this in class, but first I would like you to apply the theorem. Example 6. Find the value of each variable. So 88 to x. So 180 degrees equals to 88 plus x degrees. So x degrees must equal to 92 degrees. And for angle y, 180 degrees would equal to 100 degrees plus y, and y should be 80 degrees. Yeah. And for this one, 3y plus 3y should equal to 180 degrees. 6y and y should be 30. And that's all we need to find. And for x, 8x plus 4x equals 180 degrees. 12x equals 180. And x would equal to 15. And this one, b degrees. 4b. So 96 plus 4b should equal to 180. 84, so b is 21, and then 5a equals 90, so a should be equal to